Okay. Okay. How to use sine law. So sine law is a formula that will help you solve for either the side or an angle in a triangle. There's another major one. There's technically a so there's sine law, there's cosine law, which we can do in another one. There's actually one called tangent law, but if you know sine and cosine law, you can solve everything. You don't need the third one. They won't really teach it in high school. So the law is actually a set of ratios set up with each other. So you could say sine A, capital A, and the capital letters represent angles. So sine A over A is equal to sine B over side B, which is equal to the sine of angle C over side C. Because it's a set of ratios, you can tactically write it like this too, because you can just flip everything. It doesn't tactically matter. Whichever one is easiest for you to work with, you just use whatever you like. That should be lowercase. What's important about this is the way that I've described it, we have to like rename our triangles to coordinate with the letters. I have a lowercase a and uppercase a, lower b, lower c, upper c. Whoops, that should be a lower. It looks a bit big. But there are no letters like that on this triangle. Okay, so we've got to figure out how we're going to name it. It doesn't technically matter, but the one thing that we do got to make sure is that we set the letters up properly, and then to use sine law, we have to have at least one full ratio. That'll make more sense as I go to name this, okay? It doesn't matter which angle is angle A, or but whatever we label it, the opposite side has to be side A. So let's say I call this angle A. I must name this side A, okay? Which means if I call this angle B, that's got to be side B, and then we're only left with that. That must be side C. So that little rule for setting up your triangle is imperative. You have to make sure they're opposites of each other. Now that we have that, we can actually start taking some of our values. So angle A actually has a value. It's 55 degrees. Angle B has a value. It's 70 degrees. And side B has a length. We're trying to find out side A. We literally know nothing about side C or angle C. And that's not entirely true. We'll talk about how we actually do know a little bit. The next thing I'm going to do is just straight substitution. I'm going to take that uppercase A, 55 degrees. I'm going to plug it in. I really like this formula. I'm not sure why I prefer it, but I'm going to use that one, okay? It doesn't matter which one you use. So we're setting up the ratio. We have sine. So we have sine, angle A is 55. So I'm going to replace this with the number 55, okay? Over, what would we call side A? Do we have a length measurement? No. What I am going to do is I'm going to replace it with the variable here. I mean, I could call it A, and as long as you or I personally knew that we're solving for A, that's great. Sometimes it can get confusing. We're just going to replace side A with the letter X. It literally doesn't make a difference. It's just so that we're using what's been given to us in this equation, okay? So I'm going to put X for that. For sine B, well, the angle of B is 70. So I'm going to put in brackets here, 70 degrees. And the side of B, we actually have a measurement for. It is 9.2. Finally, sine C. Do we have an angle for C?
Well, yes.
How do we have one?
Because it's like 180, I think.
Yeah, that's right.
Subtract those two.
Amazing, good. I didn't even have to point out. Great. So I'll quickly add these two. This is going to be 125. So 55 and 70. Double check. Yeah, 125. And if we subtract them, that should give us 55 again. Is that correct? 55 and 55 equals 110. That can't be right. 65.
Okay.
Did I get it? I'm struggling on my mental math. Let me double check.
You're right, 55.
Yeah, I was right. Okay, great. Which tells us something completely more about this. This is going to be 55. I'm going to plug it in here. There we go. And side C, we don't know. So I'm just going to put this letter C in there, okay? So we've got some good information. What's most important here is that we have an entire ratio, this part here. We have all the information for the angle and the opposite side. If none of our ratios have that, you actually can't use sine law. You would go and use cosine law. No, it would just mean just use a different one. But luckily we have a full ratio. So always, in order to use sine law, you got to make sure you have an angle and the opposite side. Okay, so since we have that, that's great. Now, what's neat is we have two sets of things we're equal to. I can solve for the missing piece here, which is side C, or I can solve for the missing piece here, which is x. The question is asking us for x, so kind of pointless to do the other one, so we're not going to. We'll just kind of cross that out. Not that it's wrong or anything, it's just that there's no need for us to solve for it. So we're going to reset this up. We have sine 55 over x is equal to sine 70 over 9.2. These are considered equivalent fractions. So I don't know if you remember equivalent fractions, but there's an easy way to make them not fractions anymore, is you could do a cross multiply, and it would get rid of all the fractions. So I'm going to cross multiply, which just means I'm going to multiply that by x, and this by 9.2. So a quick way of writing it is 9.2 times sine 55 is equal to sine 70 times x. Okay? Now the goal is to isolate x, right? Right? That works. The goal is to get x by itself, because that's what we're trying to solve. So I now have to move, and if you're pretty quick with this, you can do it very quickly, but I'm going to do each one step by step. We now have to move our sine we now have to move the sine 170 to the other side. And in order to do that, we technically divide by both sides by sine, not 170, but 70. Okay. When we divide both sides by sine 70, essentially what happens here is, it's very commonly known as canceling out. You're technically creating a 1, but I'm going to move the equation up here so we have some room. And we're going to be left with 9.2 times sine 55 over sine 70 is equal to x. This is it. In order to do this, you just need a calculator. Punch it in. Technically, sine 55 is some number multiplied by 9.2, then divide by whatever sine 70 is, which is another number, and that's what your x value is going to be. This program doesn't have a calculator on it, so let's do it together really quickly. Let's see if I can bring up a calculator. I'm going to say it out loud, what we're calculating. Okay, so 55 sine is, so I got 9.2. When I do sine 55, I'm going to do a little rounding, 0.819. Is that good? Is that what you got? And we'll do sine 70 at the same time. 70 sine is 0.9397-ish, okay? Now it's just multiplying, dividing some decimal values. So 9.2 times 0.819 gives me 7.5348. I still got to divide by 0.9397. I know I'm just kind of rounding off numbers, but then we divide 0.9397, and we got 8.01. Okay, this is also really important. We got to make sure this value actually makes sense. So I'm going to do a little rough sketch of this here, this triangle. We just solve for side x. So this should be approximately 8 centimeters, right? We're going to say it's that. This was 9.2. This was 55. This was 70. And this was 55. Now, what's neat about this is this is an isosceles triangle. That means this side is approximately 8 centimeters too. That could be very well true. To logically make sense of a triangle, take a look at the opposite angles. Okay, so in this case, 70 and 90, and 55 and 8. Think of, I don't know why I use this example, like a crocodile's mouth opening. If you think of a crocodile that only, oops, I need a pen here. I'll use green. Oh yeah, so relevant for this crocodile. I'm gonna give it teeth, yay. So if the crocodile's teeth open, if it only opens its mouth a small amount, the distance between the teeth is small. So I'm gonna say small amount, small amount. But if the crocodile opens its mouth very large, obviously more scary for us, This is a big opening. That means this would be a big side. So using that concept, this angle is larger than 55. So is this side larger than this side? Does that check out? So the side opposite of 70, how large is it? What's the value?
9.2.
Yeah, 9.2 centimeters. And the side opposite 55 is 8 centimeters. So is the 9.2 larger than the 8?
Yes.
Yeah, so that logically checks out. If you were to ever get a scenario where your opposite side of the larger angle was smaller than, the other way, it doesn't make sense. We've made an error somewhere, so that's like a mental way to go back and check, okay? This technically makes sense. I mean, this is not a great way to do it, but it's not far from each other. Like 70 and 55 are relatively close. These are relatively close. It's logically making a bit of sense, okay?